So as you are writing those down, let me explain some pieces of the parabolas. Okay? Hyperbola. Thank you. Hyperbolas. So every hyperbola has a center. The center is not on the hyperbola. It's just in the middle, kind of like the ellipse. Okay? So every hyperbola has a center. It's really important for you to find that center. That's going to be where your asymptotes radiate from, and finding the asymptotes is vital to the graph. You have to graph the asymptotes before you draw the arcs. Okay? So your order of graphing is kind of like this. First, you're going to find the center, which is still HK. All right? Then you're going to find the asymptotes, which are just lines. We'll talk about how to graph them in a minute. Center, asymptotes, then you need to find the vertices, okay? The vertices are where your parabola, or where your arcs of your hyperbola are going to be centered around, okay? And the vertices are always in line with your center. Okay. So you have to graph those three things: the center, the asymptotes, and the vertices. Then you just draw your arcs. Okay, we're not going to take the time to actually make a table surrounding our vertices. It will take more time than it's worth. The asymptotes guide your hyperbola, so you can smush close to those asymptotes and get a fairly accurate graph from your vertices. Okay? The foci always fall inside your hyperbola arcs, just like they did for a parabola and for an ellipse. All right, so we're still going to find the foci. It'll just take us a second. After we do all that other stuff, then we'll find the foci. It's kind of like icing on the cake. It's not actually the cake. Okay, the substance of this is going to be graphing the center, the asymptotes, and the vertices. Okay, so the horizontal hyperbola. Now compare these equations really quick to the ellipse equation that we talked about. What's different? There's subtraction. Very good. For the ellipse, it was adding. That's the huge difference. Okay, because if this is subtraction, then the order matters. The one that is positive is going to dictate the opening direction of your hyperbola. So if your x is the first variable, positive variable, then you're going to have a horizontal hyperbola. If your y is first, you're going to have a vertical hyperbola. And A, what do you notice about A and B? What's different here? They stay in the same spot. They stay in the same spot. For the ellipse, they switched. So they switched, didn't they? Okay, and that was because the larger value is what determined the direction of the ellipse. Here, the larger value is irrelevant. A could be bigger, B could be bigger. It doesn't matter. A squared is the number that's under the first variable. B squared is the number that's under the second variable for the hyperbola. Okay? Does that make sense? Again, the numbers that you're going to see as denominators are the squared values. So to find A and B, you're going to need the square root. You don't square them, they are squared. So you need the square root to find A and B. And A and B are what your asymptotes and your vertices are going to depend, your foci are going to depend on. All right? Ready to do some? No. I'll start you off with ones where you don't have to complete the square. Okay? So the pie yesterday didn't get you going. The cookies today didn't get you going.
Wait, I think it was like Ziklo or something like that.
Oh dear. All right, so here we go. 4y squared minus 9x squared equals 36. Your instructions are going to be put this in standard form, graph it, which means find the center, the asymptotes, and the vertices. Okay? Now, is this in standard form? Why not? Good, you're not equal to 1. We should probably fix that. So let's get equal to 1. Okay, how do we get equal to 1? Divide by 36. So let's divide everything by 36. When I do that, what nicely happens with the 4 and the 9? They reduce with the 36. So that cancels out, and I get y squared over 9 minus 9 and 36 reduced to be what? On the bottom, very good, 4 on the bottom. X squared over 4 equals 1. Now this thing is in standard form. Is this vertical or horizontal? How do you know? You're right, the y comes first. Which case is that? Vertical. Okay, so it's a vertical. Your reasoning's there. You just have to make sure you pick the right one. I kind of remember that because y is the vertical variable, x is the horizontal variable. Okay, so this is a vertical hyperbola. The center. Anybody want to take a stab at the center? 0, 0. Very good. Did you look at your formula sheet or do you just understand it? Okay, so the center are still HK. It's still going to be the numbers that are subtracted in the squared quantities from x and y. So the center for this one is still 0, 0. This is like y minus 0 quantity squared, x minus 0 quantity squared. Okay. The asymptotes, let's do those next, okay? And I'm going to graph this thing as we go. So the center is 0, 0, right there. That's not my hyperbolas. The asymptotes are going to radiate from those. Okay, now on your, on your formula sheet, you have equations for the asymptotes. That's because they're lines. I don't care if you actually know the equations, especially at this point, okay? But I do want to point out, to graph lines, if we have a point on the line, how do we then graph the line once we're on that point? How do we get a line from there? Maybe find other points. Okay, so maybe use the slope to get to other points. Would that work? So if I gave you a formula for the slope of the asymptotes, could you then graph the asymptotes from the center? That's what I'm going to kind of do for you, okay? So on your formula sheet, I want you to look at the next to the last boxes on your formula sheet. They have asymptote equation, okay? They are a form of point slope form of a line. The slope is the number in front of the x group. So on your formula sheet, what is the slope of a vertical hyperbola asymptotes? What's the slope from the equation of the asymptotes for a vertical hyperbola? The multiplier in front of x would be the slope. The thing multiplied by x.
Is the multiplier A or C?
It's A. The asymptote equation doesn't have a C in it. Look at the next to the last line. So y equals k plus and minus what? A over b. That plus and minus a over b is the slope. If you want to box it, okay, or something, or make a new row for yourself in that table, or make a note to yourself to the right of that table or something, that's the really important part. Okay, so the slope for the asymptotes are going to be plus and minus a over b, and you need to find a and b. So let's do that right now. What's a and what's b?
3 and 3.
A is going to be 3. How'd you get 3?
Because the value under the denominator is always squared. Right?
Yes, it is. Very good. Okay, so square root the first denominator to find a. And if a doesn't switch spots, it's always the first denominator. Okay, b is going to be the square root of the square root of the second denominator, which is, you said, 2. Good. Okay. So now I need to actually figure out what the slopes are. The slopes are going to be plus and minus what? Plus and minus 3 over 2. You just plug them in. Okay, so you square root the denominators and plug them into your formula. Now, how do we slope positive 3/2 from 0, 0? Up 3, right 2. Very good. Okay, so up 3, right 2. That's not a point on my hyperbola, but it's enough information for me to graph a dotted asymptote line. Okay? There's the asymptote. There's another one. It has a slope of negative 3 over 2. How do you graph a slope of negative 3 over 2? From the center point 0, 0. Down 3, right 2. That'll work. You could also go up 3, left 2. Doesn't matter, you'll end on the same line. Okay? So down 3, right 2, since you said it. Down 3, right 2. Again, draw your dotted line. Should be the exact same angle. And a little strong. Okay? Just in the opposite direction. So those asymptotes should be symmetric around your center. Does that make sense? If I asked you to write an equation of the lines, you could use the formula, but you can also just write the equation of a line. Find the y-intercept, use the slopes. The slopes are the really important part. The center point is always going to be the point on your line. Okay, so we have the center, we have the asymptotes. Now we're ready to start graphing our arcs, which are going to require our vertices. So our vertices, and again, this is supposed to be a vertical hyperbola. So we're going to go vertically different from the center. Are we going to change x or y to vertically change the center? Y, and we're going to change it by a. Okay, so we're going to take the center, which is 0, 0, and we're going to add and subtract the a value from that. Okay, so what's the a value? 3. Very good. Okay, so we're going to add and subtract 3 from the center of 0, 0. So the center, the vertices are going to become 0, and 0 plus 3 is 3, and 0 and negative 3. So now you plot those points. Okay? Bless you. So the vertices are going to be 0, 3, and 0, negative 3. That's a vertex. This is a vertex. I'm labeling it with a V. Okay, and then from there, you draw the hyperbola. And you draw it, and you just smush close to your asymptotes. Try to make your parabolas as symmetric as possible, both around that center line as well as symmetric like to each other. Okay. What do you think? What about the foci? But do you understand the graph? Okay, the foci can always come afterwards. So the foci are the icing on the cake. Let's do them now. If you understand this part, this is the major issues today. Okay, obviously we can have ones where it's harder to get it in standard form. We'll get to those. All right, first let's work with the foci. Okay, so the foci. The foci are still going to be inside your hyperbola, so we need to add and subtract our C value. Now to find C, there's a formula for it, but it's not the same formula as it was for the ellipse, because for the ellipse, the foci need to end, like they need to be closer to your center than your vertices. For the hyperbola, they need to be inside your arc, so they need to be farther from the center. Okay, because it's like your two circles kind of go the opposite direction for your hyperbola. So your C value, you're actually going to add to your center instead. You're going to add and subtract your C value. But the formula for C changes. So anybody know what the formula for C is? How do we find C for a hyperbola? Yeah, now it's the same as it was for the Pythagorean theorem. Okay, C squared equals A squared plus B squared. Okay, so what are A squared and B squared? And we're going to add and subtract those to our center. So 0, 0, we're going to add and subtract C. And to find C, I'm going to use this formula. What are A squared and B squared? 9 and 4. Good. So 9 squared plus 4 squared equals C squared. 9 squared is 81.
Wait,
How about
aren't they
A?
already squared?
Good call. A squared is 9. B squared is 4. You answered the question I asked. I just didn't interpret it correctly. Okay, 9 plus 4 gives me 13. Good. So c squared equals 13. C equals the square root of 13. 3.6. Thank you. Okay, so my foci are going to be at 0 and 0 plus 3.6 and 0, and then I need to subtract 3.6, so negative 3.6. Let's plot those. All right, I'm going to plot them in green. So 0, 3.6. Doesn't take me all the way to 4, it takes me less than 4. So here we go, there's my focus. Okay, and 0, negative 3.6 takes me right about there. They should still be equidistant from your center. They should still be equidistant from your vertices. Okay. Again, they are not part of your hyperbolas. You can graph the entire hyperbola without graphing the foci, but they give you information about the wideness or the width of your hyperbola. Okay. What questions do you have before we do another one? And we'll do one that's similar. We're not going to go on real quick here. Now, with instruction, that took us 15 minutes to talk through the whole thing. Okay? So this is not as long as it might seem, and you will get faster at it. So let me give you another one. I'm going to leave my center, asymptotes, but the slope formula could change because the slope formula is different for the horizontal one than it is for the vertical one. Make sure you notice that. It flips, okay? All right, so next example, here we go. Huh? Okay. 4x squared minus y squared equals 16. How am I going to get this in standard form? It's not in standard form. Divide by 16. Okay, so that gives me so my standard form equation is going to be x squared over 4 minus y squared over 16 equals 1. See here, the second denominator is bigger than the first denominator. That doesn't tell you anything about the direction of the opening. Is this a vertical or a horizontal hyperbola? Let's decide that now. Horizontal, very good. The x is first. Okay, so it's a horizontal hyperbola. Now we need to find the center, the asymptotes, and the vertices. So the center, what's the center going to be? Good, 0, 0 still. You definitely have nothing subtracted from x or y being squared. Not sure if you can see the orange, so I'm going to work with a different color on there. Okay. The asymptotes. Now for a horizontal hyperbola, the asymptote slopes have a formula of what? Pull the formula off your formula sheet if you want for the slope of the asymptote. Plus and minus b over a. Very good. It switches. Okay, so plus and minus b over a for the horizontal hyperbola. So what are a and b?
4, 0, negative 4.
A is going to be
I did that.
Or 16 will be 4. A will be 4.
A is what?
A is the first number.
A is the square root of the first number.
Oh, okay.
A squared is the
2,
first number. So A is 2. Very good. What's B?
4.
4. There we go. Okay. Make sure you square root them before you do the formula. So plus and minus b over a. So 4 over 2, which is plus and minus 2 over 1. If you want to write it as a fraction because it's a slope all the way through, that's fine. You can also put plus and minus 2, throwing markers. Okay, but again, if you want to keep that as a slope because it's easier for you to graph it that way, that's fine too. All right, the vertices. Maybe I should plot some things on my graph. Anybody feel like, that's enough, let's graph it. We need to find the vertices too, but let's go ahead and graph. Okay? So here we go. My center is still 0, 0. There it is. My slopes of my asymptotes are now plus and minus 2. How am I going to slope plus and minus 2 from my center? Up to right 1. Okay, so up to right 1. And how that gives me this dotted line. How do I slope negative 2? That's fine, down to right 1. Okay, now this is supposed to be a horizontal hyperbola. So you're going to be horizontally away from your center. Which variable do you need to change then? The second value. In your center, you need to go horizontally away from your center to get to your vertices. So we're going to change the x value. Okay, so my vertices are now going to have the same y value, but I'm going to change x by what? How much do I change x by to get to the vertices?
2.
2, because 2 is your a value. Very good. You're going to add and subtract your a value, which is 2. Okay, so a gets used twice.
So you always use A?
You do. You always use a to find your vertices. And by the way, if you have trouble remembering which variable you're going to change, notice that for your horizontal, actually for either one, you're going to change the center to get to your vertices. You're going to change your center by the square root of the number whose variable it's under. So if you're underneath, if your x is first, you're going to change the x value by the square root of the denominator. Okay? So if that helps you, go for it. So my vertices are going to be what? 2 ordered pairs. Yes, 2, 0, and negative 2, 0. Let's plot those. 2, 0, and negative 2, 0. Okay, and then to draw my hyperbolas, I just go very close to my, I smush very close to my asymptotes from my vertices. Again, make them as symmetric as possible. All right, now it's time for the foci. This formula hasn't changed for C because I'm still working with a hyperbola. So the foci, let's see, I'm going to change the x values still. So my x values of my center are going to be changed by C. So now the 0 is going to add and subtract my C value. What is my C value? Let's see. What's a squared and b squared? What are a squared and b squared? 4 and 16. So c squared has to equal 4 plus 16. Right? You don't need to, yeah. They're in your original equation, or your standard form equation, I should say. 4 plus 16 gives me 20. C squared equals 20. So C equals the square root of 20, which is approximately like 4.6, I don't know,
On
4.47.
the test, will you care if we leave it as square root of 20 or if we reduce it?
No, the only reason I'm giving a decimal is because I'm going to try to graph it.
Okay.
And I can't really graph the square root of 20 easily. So you want a decimal because you're going to be plotting it.
Okay.
Okay? So my foci, so that's 2, so this is going to be 4.5. 4.47, so 4.5 rounded. Okay? And negative 4.47 or 4.5. There's my foci. So my 2 foci ordered pairs, and then I'm going to ask you what you notice about these foci versus the last one as they relate to the vertices. They're farther away. Yes? Okay, next question. What do you notice about the width of your hyperbola? It's really fat. It's really, really wide and very, very wide for its opening. It's not so narrow like the last one was. Notice the foci move further away and the hyperbola opened wider. Does that make sense? It's like a magnetic field. Okay? All right. Yeah, it's kind of like a flashlight. That's right. The flashlight moves farther away, the beam gets wider. All right. Ready for some where you have to complete the square? What questions do you have so far? That one only took us 10 minutes. The next one? I think so. If we don't, I'll finish it on the video and you can see it. Okay, and I'll put your assignment on my big campus as well.
Wait, we tell us our assignment now.
Will I tell you your assignment now? Okay. Page 687. Numbers. Only going to have a couple because they do take a while. Okay. You're going to do numbers 17, 20, and 22. Okay, 17, 20, and 22. Page 687. And I'll put that on my big campus as well. But let's do one more problem where you have to complete the square, because 2 of those you have to complete the square. And again, if we run out of time or something, I'll still have it on the video for you. We'll still go with it. Okay? 687, 17, 20, and 22.
So I don't think that was a pop up.
17, 20, and 22.
Yeah.
All right. So, let's do one more, at least. Actually, I have 2 more, but we'll do one more.
I've used up 2 pages.
This one's going to take a little bit of time to get it to standard form. So I'm actually going to take the space that's next to it over here to help get you in standard form first. Okay? And I'm going to get a marker that I know works because I don't want to deal with it. So, and you're going to laugh when this one doesn't work as well. 9x squared minus 4y squared plus 8y minus 40 equals 0. Okay, and I'm going to slide this guy over. We're going to complete the square. So, what do we need to do first to complete the square on that problem? Should probably add the 40. I have 2 squared terms, so I'm going to leave both of those variables on the same side of the equation. I'm not going to move them over, like I would for a parabola. Parabola, I'm going to get rid of the non-squared variable. These are both types of variables in squared. So, add the 40 to the other side. Probably the easiest place to start. There, that works. So, I get 9x squared minus 4y squared plus 8y equals 40. Little step to begin with to get us warmed up. Now what? We aren't close to standard form yet. So once we get everything quantity squared, then we'll be ready to divide by the number on the other side. But the problem is that I have 2 y terms.
Wait, don't you,
The x group is
Take-
already almost complete.
take the half of
Yeah.
8 and then square it?
Okay. Yes, you're going to take half of the number in front of y, but first of all, you have a number in front of the squared variable, the squared piece of y. So 9x squared, I'm going to let that guy just travel along with us for a minute. All right, but we need to factor out the number in front of y squared. So I'm going to factor out a -4. I'm not completing the square yet. I'm just preparing to complete the square. So when I factor out a -4, I get y squared. And then what do I get with this plus 8y?
Minus 2y.
Minus 2y. Minus 2y. Why did it change to minus? Yeah, because I factored out a negative. And this is where hyperbolas are trickier than ellipses, because you're going to be factoring out a negative every time for one of your squared variables, at least a -1, if nothing else. So your sign of your second term is always going to change for a hyperbola completing the square. Okay, now let's get to completing the square. First time we've done it since we came back from break. Here we go. Squared quantity group. What squared quantity gives me a middle term of minus 2y? Minus 1. Very good. Take this number in front of y and divide by 2. Okay, so that becomes minus 1. But now I have to balance the other side of the equation, because all of a sudden there's more stuff on the right than there is on the left. Or more stuff on your left than there is on the right. Okay, so I need to square the -1. And you have to multiply by -4. Good. Okay? You have to multiply it by the -4. So if I square -1, I get 1. And then multiply by -4, and I get -4. Okay, so I'm going to put a -4 on the other side. Okay? Which gives me 36. So 36 is really my right-hand side. Okay? Now we are almost in standard form. Madison, your whole idea of you've got to get a 1 on the other side, now is where you're going to do that. So what do you do to do that? Divide everything by 36. All I did was rewrite that line so it looked a little nicer. Okay, divide every single thing by 36, and you're going to get x squared over 4 minus y minus 1, the quantity squared, over 9 equals 1. Hey, we had 4 and 9 a minute ago, but they were switched. Okay, so it's still a little different. So my standard form is x squared over 4 minus y minus 1, the quantity squared, over 9 equals 1. Let's see if we can do this. What's the center? Anybody? 0, 1. Very good. Is this a vertical or a horizontal hyperbola? Which is it?
Horizontal.
Horizontal, because x is first. Notice this center is not 0, 0 anymore. That would change your asymptote equations, but it's not going to change your slope. Your slope radiates from the center. All right, I'll finish this on the video. The asymptote slopes for the horizontal hyperbola are going to be plus and minus b over a. All right, so I need a and b. A is going to be 2. B is going to be 3, because a is the square root of the first denominator and b is the square root of the second denominator. Okay, so plus and minus 3 over 2. Let's draw the graph a little bit. So my center is 0, 1. That's right there. My asymptotes have a slope of plus and minus 3 over 2. So I'm going to rise 3 and run 2 and go down 3 from my center. So 1, 2, 3, and run 2. So here's my asymptotes. Okay, now I need my vertices. My vertices are going to be a units away from my center.
No, they aren't. Stop.
So I'm going to go a unit horizontally. So I'm going to change the x value by 2. So 0 plus and minus 2. And I'm still going to have the y value of 1. 2, 1, and negative 2, 1 are my vertices. Horizontally, let's see, 2, 1. Notice it's still in line with your center. and negative 2, 1. Your hyperbolas look something like this. Okay? Now we're ready for the foci. Okay? I need C. Let's put it right here. Foci. C squared equals A squared plus B squared. So C squared is going to equal 4 plus 9, which is 13. So C squared is 13. C is the square root of 13, which we did a second ago. I think it came out to about 2.6, or 3.6 rather. Yep, 3.6. So I need to add and subtract 3.6 from my center. So I'm going to go 3.6 units to the right and 3.6 units to the left.